So yesterday we did, what was our vocabulary? We did sum, difference, product, factor. Okay, so today we're adding on to that with division. So the first word we have today is quotient, which is what?
The
answer. So the quotient is the result when the dividend is divided. Sometimes we'll get fill-in-the-blank notes. Sometimes we'll be writing them all ourselves. We'll switch it up. But the quotient is the result when the dividend is divided by the divisor. That is the answer to a division problem. All right, our dividend, a number that is being divided or split up by another number. Your dividend would be like your larger number, your whole part that you're splitting into smaller groups. If we had a group of 50 jelly beans and we're splitting them between 5 friends, okay, so your dividend is the 50 that's being divided up. One thing I want you to know, when we look at a division problem, look at it at the bottom. This is how we're going to be writing our division problems when we use our traditional algorithm, okay, to work them out long division. Some people call this like a division house, okay? Our dividend is the one that's where?
In the den.
It's in the den. It's inside. So we're going to say the dividend is the one that's in. So the dividend will be the one inside the house. And of course, our divisor, the divisor is the number by which the dividend is divided. Absolutely. So that would represent your 5 friends. So 50 jelly beans is your dividend. Divisor would be the 5 friends. Do squeeze an M in there.
Okay.
I didn't write this one out, but squeeze that in there. Okay. The divisor, to help you remember it, we can always say he is at the door. So the divisor is at the door. Now, like yesterday, when we talked about the algorithm for multiplication, out of curiosity, anybody look at your shampoo bottle?
Yes.
You did?
Yeah.
Wash, rinse, repeat. There's your algorithm, okay? So with division today, we're doing another algorithm. Happens to start with DMSCB. Does McDonald's sell cheeseburgers? Or does my sister chew bugs? Whichever one you want to use. But we all know the D stands for division. The M stands for multiplication. S. Alright, what about the C?
Check.
Stands for check. And we'll talk a little more about that in just a minute.
Bring it back.
And then finally, bring it down. Or bring down. Okay? So we have divide, multiply, subtract, check, and bring down. Now, you can see division problems written of 3 different ways. Okay? The first would be like this, where we have our dividend, our divisor, and our quotient. We could see it written horizontally, where you have the dividend, divisor, and quotient, using the division symbol. But there's one other way that's not on here. Does anyone happen to know? It looks very similar to this division sign. Noah.
Vertically.
When we write it vertically, what else does it look like? Just say. Anybody?
%.
No, not a percent. What if I were to replace these 2 dots with numbers? A fraction. Guys, a division is also represented with fractions. Let's say I have an improper fraction of 4 over 2. What is 4 divided by 2? 2. Well, if I have an improper fraction, 4 over 2, which is 4 halves, that also represents 2. So fractions are another way we can show division. When we get to algebra, we'll be seeing a lot of this, okay? That fractions also represent division. To me, it's kind of cool that the fraction looks very similar to a division sign. Because a fraction represents division. If you eat a fraction of a pizza, you had to divide it up first. Alright, so let's start a couple of problems together. Alright, we're going to use our traditional algorithm. We're always going to work our problems out using the house, the division house. So we have 298 divided by 7. Let me swap pens here so you can see it better. 298 divided by 7. Dividends always first, divisors always second. I had a student, he's a senior in high school now, but in 5th grade, we were working on division, and he said, I just don't like looking at the whole number. Hold tight. I don't like looking at the whole number. So here's what we decided to do, and if this works for you, it's a very high-tech tool, okay? It's a sticky note. And the sticky note can come in here. Can 7 go into 2? No. Can 7 go into 29? Okay. Am I looking? Hang on. Stay with me. Am I looking at the whole entire number? I don't need to see 298 because I'm not focused on 298. I'm only focused on 29 right now. So, how many times will 7 go into 29? 4 times. So I've taken care of the divide part. Now I'm going to multiply. What's 4 times 7? Okay. Next thing I'm going to do is subtract. Now, here's where the check part comes in. What I'm checking is to make sure that this number is smaller than my divisor. Why would I want to make sure it's smaller than my divisor?
Because if it's not, you can subtract it again.
Absolutely. We can take a whole other group out. If we had gone with 3, let's say I have 29 jelly beans, I'm splitting them among 7 friends. Okay? If I gave everybody 3, I still have 8 left over. Everybody can get 1 more. So now everybody has 4, and this time I only have 1 left over. So yes, this number right here always needs to be less than our divisor. Once we've checked that, do we have anything to bring down? We do. At this point, we now go back to the top because our algorithm starts all over again. So 7 goes into 18. 2 times. Now we multiply. 2 times 7.
14.
Now we subtract. 18 minus 14.
Remainders or the decimals?
Hang tight with me. We'll get there, I promise. Just stick with me, okay? Alright. Now I'm checking. Is 4 less than 7? Absolutely. Do I have anything else to bring down? No. Now, in a couple of weeks, when we get to decimals, we will turn our remainders into decimals. But I need you to be able to recognize fractions being the same as decimals. So right now, we are writing remainders as fractions. Why would we not use the little r as a remainder?
Because you want to make it a fraction.
We do want to make it a fraction, but anybody know the real reason why?
Because it's...
Yes.
We're not third graders?
Well, that's a good point. When you get to 7th and 8th grade and you're in geometry and you start learning about circles, there's something called a radius. And that radius is represented by a lowercase r. So we don't want to write, my answer is 42, radius 4. We want to make sure we know we're talking about a remainder. How many of you like leftovers? We had leftovers last night. We had leftover tacos. Okay? Well, in math, we're going to make sure our leftovers don't get forgotten about and don't turn green in the refrigerator. So we're always, guys listen, we're always putting our leftovers on the top shelf of the fridge. So, for you to remember where that remainder goes, your leftovers always go on the top shelf of the fridge. Your remainder becomes your numerator and your divisor will always be your denominator. What that means, like we said, fraction's the same thing as a division. When I have 4/7 of something, do I have a whole? No. I'm working towards having a whole. I have 4 out of 7, but I don't have 7 out of 7 yet. So I have 4 out of 7 left over. Okay? All right, let's try one more together. This time we have 300 divided by 45. Okay, looking at this. Can 45 go into 3?
No.
Can 45 go into 30?
No.
Can 45 go into 300?
Yes.
Now, I don't know about you, but I don't randomly go around counting by 45. That's just, I don't, okay? I could if I really sat down to do it, but can I estimate?
Yes.
Yeah. What's 45 close to?
50.
50. Can I count by 50s?
Yes.
Oh, easy. So how many times will 50 go into 300?
6.
Let's try it. Now, remember, when you're putting your numbers up here when you've divided, you want to make sure, and that's a little too far to the right, but it goes over the number that you're talking about. I'm not talking that 45 will go into 3 6 times. I'm not saying 45 will go into 30 6 times. It will go into 300 6 times. Now, if you like to go to the edge of your paper and do your multiplication on the side, that's perfectly fine. I want to show you how I think of it in my brain, and if you need to do it differently, that's great. What are we doing after we divide? Multiply. So I'm going to say 6 times 5 is 30. I'm going to put my 0, carry my 3. 6 times 4 plus 3, 27. So I've done all of my multiplication right here. Hang tight. All of my multiplication I've done right here. If you need to go to the edge of your paper and work it out, that's perfectly fine. At this point, I've divided, I've multiplied, now what do? Subtract. What's 300 minus 270?
30.
Okay. Did you have a question so far?
I was just want to say something. The way I did it was I just multiplied 5 by 6 and then moved that.
Absolutely. Yep. All right, so here we go. With 30 left over, is 30 less than 45?
Yes.
Yes. Do we have anything else to bring down?
No.
So we're going to write our fraction 30 over 45. Am I done?
Yes. No.
Why do you say no? She recognized we can reduce that fraction. Okay? So, we have 6 and 30 over 45. What number can go into both 30 and 45? 5. Is there a larger number? Let's try 5. Okay, so we have 6. How many times will 5 go into 30? 6. How many times will 5 go into 45?
9.
I get to this point, I can still reduce that fraction. That's right, 3 can go into both. So 3 goes into 6 2 times, 3 goes into 9 3 times. Okay? This is your ultimate, final, most correct answer. At this point, if you write 6 and 30 over 45, I won't take off points. I will give you credit for this right now. But as we're moving forward, we need to learn and we need to get into good practice that all fractions need to be reduced to lowest terms. Okay? Any questions so far? Long division. Hopefully this is still all review. Yes, so far? Awesome. Okay. Let me stop this real quick.
Bye, guys.
Bye.